Professor Douglas Osheroff is a 1996 Nobel laureate in physics from the Department of Physics at Stanford University. He was awarded the Nobel Prize for his discovery of superfluidity in the isotope helium-3. Professor Osheroff noticed a jump in the heat capacity of the liquid helium-3, indicating the conditions required for helium-3 to change from an ordinary liquid to a superfluid. His discovery sparked intensive research into superfluid helium-3 and other so-called quantum liquids, as it enabled scientists to study the types of quantum mechanical effects in large, visible systems that could previously only be studied at the atomic and subatomic level. Professor Osheroff's work was considered a breakthrough in low-temperature physics, and in the course of his research on helium-3, he developed an early form of magnetic resonance imaging, but only in one spatial dimension.
Hello and welcome to this special edition of Talk Vietnam for an exclusive interview with 1996 Nobel laureate in physics, Professor Douglas Osheroff from Stanford University. It's our honor and privilege to have him here with us. Today we will learn about the discovery that won him the Nobel Prize, as well as how science changes our lives. Hi, Professor Osheroff. How are you today?
Fine.
How was your trip to Vietnam? Is this your first time?
First time to Vietnam,
Yeah.
But we actually went to Thailand first before coming here. So by the time I got here, no jet lag anymore.
Excellent. So what was your first impression of Vietnam upon your arrival?
Well, it was interesting. I mean, I didn't know what to think about it because I was just very happy I hadn't gone to Vietnam earlier, a.k.a. during the war, the American War.
So what made you decide to donate your precious time and energy to the 4th ASEAN event series, Bridges, Dialogues Towards a Culture of Peace?
Wait, invited me. I'm very bad at saying no, but it seemed to me that it was a really valuable and interesting program and something that I would enjoy. You know, I do a lot of this. I particularly enjoy. I've actually brought demonstration lectures to first grade classes.
Wow.
Yeah, mostly, you know, if I'm doing demo stuff, it's in the United States because it's kind of hard to get all that stuff overseas. But you know, I think, you know, science is fun, and I like to share that with other people.
Excellent. Upon his arrival to Hanoi this time, Professor Osheroff joined a press briefing at the Hanoi Hilton Opera. Let's have a look.
Hanoi is the second destination after Bangkok for Professor Osheroff on his tour for the 4th ASEAN event series, Bridges, Dialogues Toward a Culture of Peace, organized by the International Peace Foundation and the Vietnamese Ministry of Education and Training. The event drew great attention from the Vietnamese mass media.
I really think that what this exercise for me is all about is sharing my excitement toward science and try to explain to you how science indeed is discovered, new science, and how we can use that science to improve the lives of all of us.
To be able to invite them to Vietnam, the organizers had to contact the guest scientists 2 years in advance. Visits like these benefit Vietnam in many ways, according to the planners.
These are not one-time visits only, but visits with many fruitful returns. We want them to become somehow ambassadors of Vietnam, goodwill ambassadors, and also tell about their good experience here when they go back to the United States or to Europe, what they have learned here from Vietnam. We want them also not only to speak, not only to talk, but also to listen, to learn more about Vietnam, and to see how they can be of benefit for the development of the country in the long run.
Members of the audience asked Professor Osheroff many questions at the event. The answers he provided satisfied Vietnamese journalists, including Lê Thành Y.
I think it really will behoove.
Giáo sư đã đề ra một vấn đề như thế này. Chúng ta phải tăng cường đưa các bạn trẻ đi học mà theo các hợp đồng, mà thậm chí này các bạn trẻ đủ trình độ và điều kiện giúp được các giáo sư, thì người ta sẽ trao thêm tiền, trả công cho họ trong những cái việc họ hợp tác làm ăn. Cho nên tôi cho rằng đây là một cái hướng mới mà có lẽ mình cũng nên chấp thời cơ.
Right after the press conference, Professor Osherup restarted his hectic schedule of meetings with Vietnamese policymakers, lecturers, and Vietnamese physicists and students.
You were always interested in science from a young age, and your parents had a great influence, and they facilitated that interest of yours. Can you tell me a little bit about their influence on you when you were a young child?
Well, I guess I was, I think, 6 years old when I got an electric train for Christmas. It was a typical toy, but by the end of Christmas Day, I'd taken the locomotive apart to get the electric motor out.
Excellent.
And this was a watershed moment. I think if my parents said, "You destructive devil, go to bed without your supper," we wouldn't be having this conversation now. But my parents, particularly my father, was fascinated with my fascination for mainly electricity and magnetism.
In an interview, you once said that you may have well have been a danger to your family as a child, since you had an interest in gunpowder and high voltage electricity. Can you tell me a little bit about that?
Well, yeah, the gunpowder, I don't think that was too much of a danger, but I like to blow things up. It's true. High voltage electricity, I think I probably, there was one time I charged a bank of capacitors, which I'd gotten. My father had a patient. He was a medical doctor, my father was, and he had a patient that worked for the telephone company, and he would bring stuff to my father to give to me, and I could generally find ways of making that stuff nearly lethal. So I had a bunch of capacitors, and I charged them all up to 600 volts, and then, mistakenly I discharged the capacitors across my body, and the next thing I knew, I woke up on the other side of the room, and I had no recollection of being shocked by this thing. It just, it was one of these things. So,
Wow.
I probably was kind of dangerous.
You're a Nobel laureate today, but back in the day in school, were you the best in your class?
Well, when I was actually a slow reader. In fact, I still am. So I think in first grade, I probably didn't look very smart, but probably by sixth grade, I looked pretty smart, and I think after that, I was usually number one in my class. But
Excellent. So, where were you when you received the news that you had won the Nobel Prize back in 1996?
Well, so I was in bed asleep. The call came at 2:30 in the morning.
Oh, wow.
And so the phone rang. Now, the phone is on my wife's side of the bed, but she never picks it up. So I jumped out of bed, ran around, picked up the phone. I said, "Hello?" And the person on the other end said, "Hello, hello, is this Douglas Osherup?" I said, "Yes, it's 2:30 in the morning." And he said, "I know that, but I have a matter of some importance, if you will. I am Carl Uf Jakobsen, Secretary General of the Royal Swedish Academy of Sciences." In that moment, of course, my jaw drops down to my navel because I know exactly what this phone call is about. And so he tells me that I'm getting the Nobel Prize and who I'm sharing the prize with, and which was good. That was kind of important because there were two professors that basically trained me and provided the research capabilities and everything. Anyway.
So what did you do right after you got that phone call?
Well, I felt that my life was changing, and it was one of these moments that really a watershed moment in my life, and I think I understood pretty well that things were going to be different after that.
In the 1930s, another strange phenomenon was observed. This rapidly evaporating liquid helium cools until at 2 degrees above absolute zero, a dramatic transformation takes place.
Suddenly, you see that the bubbling stops and that the surface of the liquid helium is completely still. The temperature is actually being lowered even further now, but nothing particular is happening. Well, this is really one of the great phenomena in 20th century physics.
The liquid helium had turned into a superfluid which displays some really odd properties. Ordinarily, this container with tiny pores can hold liquid helium. But the moment the helium turns superfluid, it leaks through. Superfluid helium can do things we might have believed impossible. It appears to defy gravity. A thin film can climb walls and escape its container. This is because a superfluid has zero viscosity. It can even produce a frictionless fountain, one that never stops flowing. Superfluidity and superconductivity were baffling concepts for scientists. New radical theories were needed to explain them.
So what actually triggered your co-discovery of superfluidity in helium-3?
I thought we were going to be studying solid helium-3, and in fact there were two people in the research group, two graduate students that were doing rather similar experiments. But the technique that we used to get cold involved the solidification of liquid helium-3. So we had a mixture of liquid and solid helium-3 in the cell. And I was I was basically converting liquid to solid at a constant rate, and the pressure was rising as it should if things were getting cold. And then all of a sudden there was a very sharp decrease in the rate of cooling. And I, of course, thought that was terrible. And that was the signature of superfluidity in helium-3, actually.
Do you think that luck may have had a role, though tiny, in all those landmark discoveries made by you and other Nobel laureates?
Well, you know, what I say is that bright people manufacture their own luck, you know, by being at the right place at the right time, doing something different that no one's done before, and developing technologies that allow you to probe nature in a new and different realm.
Looking back at your career path so far, do you think it was a tough one? And what was the greatest challenge that you have faced?
I don't think it was tough. It was something I, you know, always enjoyed doing. I guess, you know, the 4 years at Caltech were the hardest. Okay, I mean, the Caltech was really tough, and you know, I took physics from Richard Feynman, who was kind of my freshman class started out 192 students, and the beginning of the second year, only 120 returned. So that gives you some idea what it's about. But you know, for me, it was fantastic, but it was a lot of work. I mean, you know, I think I think people that don't challenge themselves don't go anywhere.
Yeah,
right?
That's true. Very true. So after graduating from Caltech, you went on to Cornell University in 1967. During that time, you and your colleagues, David Lee and Robert Richardson, made the discovery that later brought you the Nobel Prize. Can you tell me a little bit more about those years?
Well, so I came to Cornell, and the first semester, you know, I was a new graduate student. I wasn't attached to a research group yet, although I was teaching for Dave Lee, so he knew who I was. And eventually I got into the low temperature group, and because, you know, there were two talks, actually, that first semester when I was there on low temperature physics, and it looked to me like this would allow me to look at nature in a new and different realm, and that's why I went into low temperature physics. And so I started, it was a magical time, because there were these new refrigeration technologies that were just being developed, and I was kind of excited. Part of that, So at first it was a matter of getting cold and maintaining very low temperatures. I mean, we could get down to a fraction of a thousandth of a degree above absolute zero. And then I was doing this experiment, which was really mostly testing out the technology. And everything was cooling very nicely, and then all of a sudden there was a rather sharp decrease in the rate of cooling, and of course, I was very unhappy to see that, but that was the signature of superfluidity in helium-3.
So you you shared the Nobel Prize with Lee and Richardson, who were both senior researchers at that time while you were a graduate student. That probably doesn't happen very often, does it?
I don't know. I mean, I think for me it seemed quite natural, and it's funny that the Nobel Prize was split 3 ways, and so I got only a third. But the Nobel Prize is not about money. It's fame and glory, I suppose.
How do you think you could emerge so rapidly and so successfully? What led to that?
Well, I must say that after discovering superfluid helium-3, of course, I immediately focused in on that and did what when you discover a new phenomenon or new field, the thing you want to do is skim all what they call it, skimming the cream off the top. You do all the good experiments first. So I tried to do as many of those as I could, and it was amazing because, well, of course, very shortly after the discovery, I moved to AT&T Bell Laboratories. Now, the bad part about that was that I had to start all over again, building up a new laboratory.
Yeah.
But Bell Laboratories was very generous to me, very supportive of my research. And so I had a technician, but in fact, the technician only took one set of data for me in the many years that I was at Bell Labs. I never understood that data. So I would basically farm my technician out to other people.
Yeah.
And I thought that was a good use of his time, and I was happier working by myself.
Yeah. So how has your Nobel Prize winning discovery been applied so far?
Well, superfluid helium-3 was, I guess, to use a technical term, the first unconventional BCS state. Now, BCS stands for Bardeen, Cooper, and Schrieffer. They were the 3 people that explained the microscopic origins of superconductivity in metals, obviously. And superfluid in helium-3 was, in fact, a broad generalization of that theory, but where there was very different, because in the case of a superconductor, the attractive interaction that leads to the formation of Cooper pairs, they're the entities that really condense, was through the lattice. Superfluid helium-3 has no lattice. It's all a liquid. And so it was really very different system, and it was, man, I had really world-class theorists that were popping their heads in my lab every day asking me what was the news and stuff like that.
During his visit to Vietnam this time, Professor Osheroff visited the Hanoi National University where he lectured on how science changes our lives. Let's take a look.
The conference hall of the National University of Vietnam today is full, since every student wants to see with their own eyes a Nobel laureate. A ceremony was held today to commemorate the honorary doctorate that the president of the university presented to Professor Osheroff, the second time such an honor has been given to a Nobel laureate.
Thông qua việc vinh danh những nhà khoa học xuất sắc có cống hiến lớn lao cho nhân loại như giáo sư Osheroff và các nhà giải Nobel khác, thì cả những nhà khoa học xuất sắc thế giới và chúng ta hiểu biết lẫn nhau hơn, và như vậy thì cái cầu nối, cái hợp tác giữa Đại học Hà Nội với Đại học Stanford nơi giáo sư Osheroff làm việc, cũng như với các trường đại học Hoa Kỳ khác và các cái tổ chức khác nói chung sẽ được phát triển.
Nguyễn Đức Hoài is among the lucky few who met and talked with Professor Osheroff during his previous seminars abroad. Meeting him again in Vietnam reminds White of earlier events.
Trước đây trước khi gặp giáo sư thì tôi nghĩ rằng ông Osheroff là một ông rất là nghiêm khắc và rất là kỹ tính, bởi vì chúng tôi đã gặp rất nhiều nhà khoa học và họ có những cái nguyên tắc, nhưng mà đối với ông Osheroff thì cái cảm nghĩ ban đầu về một cái nhà khoa học mà rất là thân thiện và gần gũi, và ông ấy có thể chia sẻ cùng uống một cốc nước trà và chia sẻ tất cả các câu chuyện với chúng ta.
On these rare occasions, meeting with a Nobel laureate, students ask the professor many questions. The questions could be about the scientist himself, his research method, or which area they should focus on in the future.
Biggest wishes. I don't know what to tell you, but in fact,
it's I think you have to, at some level, if you're doing basic science, part of the joy of doing basic science is answering questions that no one knows the answers to, and there's a lot of joy involved in that. But in fact, I think if you want to maybe better mankind's position on, you know, you can come up with new technologies and things. That's not basic science anymore. That's really applied science, and I would dare say that I think there's a lot of applied science that is very useful, very enjoyable to do, and in fact, I think you don't have to worry whether something you're doing, such as maybe superfluid helium-3, actually will ever be useful for mankind. So I think it's a decision that you have to make.
Cũng như lúc nãy em đã đặt câu hỏi cho giáo sư, thì hiện tại bọn em ở trường Trung học phổ thông chuyên khoa học tự nhiên cũng đang có một câu lạc bộ khoa học. Em rất mong muốn là nhờ những buổi nói chuyện như giáo sư ngày hôm nay thì các bạn học sinh sẽ có thêm được tiếp lửa niềm đam mê, và có thể biết đâu sau này thì sẽ có ai đó đạt giải Nobel chẳng hạn.
Em thích cái câu là đừng bỏ cuộc khi gặp những điều khó khăn trong cuộc sống. Thì nó cho em một nỗ lực để tiếp tục cố gắng trong học tập và theo sự nghiệp sau này.
Winning a Nobel Prize is the wildest dream for students of science here today. But who knows if someone can attain something great thanks to this talk? That fact will only be known in the future.
You had a lecture at the Hanoi National University here in Vietnam. You spoke about how science changes our lives.
Yeah.
How does it actually happen? How does it change our lives?
Well, I mean, take an example. Marconi invents the radio or whatever, radio waves. And that allowed us to communicate a lot faster. And so, you know, people communicate. That's very important stuff, right? And I think it's kind of course, Marconi didn't prevent World War II from happening, so there's still a lot of misunderstandings between people. But I mean, that's one example. I think Fleming discovering penicillin is another example where, you know, that was the first of many drugs which could cure disease and prolong life and things like that. So you know, there were just a lot of things, and in every case, I would say, you know, you can see an advance in science that leads to better life for human beings. On the other hand, you look, for instance, an example is burning coal. I mean, we have to go back a long time now, but we're talking about Watt, for instance, invented the steam. He didn't invent the steam engine. He actually used thermodynamics to perfect the steam engine. And then that allowed people to actually create factories in cities rather than where there was falling water. And that really changed things. So these are just some examples, but you know, nowadays, I think, if anything, the rate of change of our lives is a lot faster.
So, do you have any specific advice for young Vietnamese students who choose, who wish to pursue physics as their lifelong career?
Well, first of all, it's be prepared for great adventure, because I think it is an adventure, and there's still a lot that we don't understand. So, but I think young people need to, first of all, well, okay, there are two kinds of physicists. There are experimentalists. I'm an experimentalist. I work with my hands. And there are theorists. And, you know, I think people have to realize, first of all, what they're good at. And I've always been good at building things and measuring things and stuff like that. And whereas, you know, mathematically, all this complex stuff, I don't have much patience for that. So for me, I knew right away that I would become an experimentalist. That was pretty clear to me. But I think it's the first, most important thing is that people have to know what they're made of, what they enjoy, what they're good at, and then match that to a career.
think about the importance of self-reliance in scientific research?
Well, it's kind of interesting. I think for science to progress as quickly as it has is largely because of the very, I think, effective communications between scientists. So you know, for instance, I discovered superfluid helium-3, but then I worked with the theorist who then, you know, allowed, you know, us to understand helium-3. And so I don't think that many really effective physicists work all by themselves. They tend to work together. At least that's certainly been my experience.
So teamwork, you say?
Teamwork, yeah. Yeah, but not necessarily a team of, you know, you need people on the team that have complementary skills.
Yeah.
Good.
So you're now a professor at Stanford University. What can you tell us about your teaching experience there?
Well, you know, it's you teach a lot of different kinds of classes. One class that I really enjoy teaching is an advanced lab class. Students, typically in groups of 3 or 4, will choose to do a single experiment in low temperature physics, and then they have to design and build, with my help, of course, the equipment to do that. And so it's like a good experience for them. For a long time, I would teach one term of our engineering entry-level physics class. This counts as a double teaching load, which means that I get out of teaching for one term. But that, you know, you have a lot of students then, and it's kind of fun because some fraction of them will come to my office for office hours. And, you know, that fraction is not very large. If the class would be, you know, 300 or something like that, and maybe I would get 30 or something that would come to my office. But you get to know these students, and later, you know, you write letters of recommendation for them for graduate study or something like that. It's kind of fun. Yeah.
That sounds really great for them. I don't know for you.
Yeah. Well, no. I mean, look. I'm not their parents, but I think of them a little bit as my offspring. It was kind of interesting. You know, even after I got the Nobel Prize, so every 3 years you have to renew your research grants. And I had a grant with the Department of Energy and one with the National Science Foundation, and I would ask these guys for, you know, every 3 years I would ask for an increment, so I get a little bit more money. In the 24 years that I was at Stanford University, well, I still am, but I'm not doing research anymore. Anyway, I never got an extra penny. So after a while, what used to support 2 graduate students would only support 1, and then it was a lot harder to do the research and stuff like that. So, you know, I don't know what to say. It's tough. It's tough even in the United States, but it's got to be tougher for you guys here because you've got less money.
As part of his activities in Vietnam this time, Professor Osheroff met with the leaders of the Ministry of Science and Technology. Let's have a closer look.
As in other countries, young people in Vietnam tend to choose careers with more development opportunities, and that's one reason basic science has become less appealing as a college major. This topic was a major concern raised at the meeting between Professor Osheroff and Deputy Minister of Science and Technology Chu Ngọc Anh. Professor Osheroff's visit may have influenced the current class.
Trong cái cuộc nói chuyện thì rõ ràng giáo sư Douglas Osheroff cũng đã thể hiện cái thiện chí rất là cao của mình. Đặc biệt, xin quý vị các bạn nhớ rằng đây là một cái tên tuổi rất lớn, và đối với tôi là ngành vật lý thì những cái phát hiện từ cái nội dung mà ngài được giải Nobel cùng các cộng sự này sẽ mang một cái dấu ấn hết sức tích cực cùng với lại thiện chí của ngài, và chúng tôi tin tưởng chắc chắn rằng dù đây là cái dấu hiệu khởi đầu, những cái như đó là cái bước khởi động hết sức tích cực, và giáo sư chắc chắn sẽ là cái cầu nối hết sức là hữu ích trong tương lai với cái cộng đồng khoa học công nghệ Việt Nam.
With its strategy for scientific development, the Vietnamese government set up the National Foundation for Science and Technology Development in 2008 with an annual budget of nearly $10 million. The foundation aims to fund scientific projects by domestic researchers and narrowed the gap between Vietnamese and international science.
During the reception held in your honor, leaders of the Vietnamese Ministry of Science and Technology suggested that they would be grateful for your support in the future. Do you have any plans to return to Vietnam?
We'll have to see how that works out. I mean, it's very easy. A lot of things can be done at a distance now. Coming to Vietnam, of course, is a long ways away, and it's a lot of jet lag. But, you know, I never say never. But I think, you know, having some sort of relationship over the internet is so easy now. So we'll see how that evolves with time.
So in a developing country like Vietnam, how do you think we should invest in science, including physics?
Oh, well, you're asking me. I mean, first of all, I don't know how much money you guys have to invest, and so it's a little bit hard to say. But there are two issues. One is training young people, and so obviously I don't know what you know the basis is right now in terms of how many professors you have and what their expertise is and stuff like that. But certainly people, I would guess you have a pretty well-trained set of professors at universities, and what you're probably thin on, I would guess, is equipment and that sort of thing. And like I said, you know, most of the equipment that I used in the discovery that won a Nobel Prize, I built with my own two hands. So, but I'm not going to say that everyone's going to do that. Okay, so that's a little bit tricky. But certainly there are a lot of universities that have old equipment, and certainly we've shipped old equipment off typically to places in South America, because that's, you know. So I know that certainly is a possibility. I don't know whether for American Physical Society, does it have any programs for what you do with used equipment? I don't know the answer to that right now.
But what do you think are the strategies or approaches that Vietnam should consider for the future?
Oh, okay. First of all, I think no one's going to be interested in doing something if they haven't been exposed to it, is my guess. And so as undergraduates, I think it's good for students to get involved. In the United States now, certainly the opportunities exist, not for every student, but for a lot of students to work in a research group. I think that there are opportunities, and it's kind of really great, I think, for undergraduates to get involved in research, because first of all, you find out what kind of research that excites your passion. And you have to be careful when I say passion, I'm referring to passion for science. and you find out what you're good at, and you also learn some skills, and so that's an important thing. And obviously not, I mean, I don't know how many, we have vastly more undergraduates at Stanford, I guess, than we can have working on research programs. But not all students choose to do that.
So far, how have you helped developing countries like Vietnam in their scientific research?
Well, I go to a lot of different places, and I try to give them good advice if I can, and I try to stimulate young people. Now, I'm not going to give them lots of money because I don't have it. Okay, but you know, I think hopefully that when I leave a country, that people have at least a some idea of where they're going to get the equipment to allow them to do the science that they would like to do.
And many researchers, after years of studying and working abroad, do not want to return to their home for work. What's your advice in this case?
That's a tough one, because first of all, I think that your researchers will be better trained if they can come and work in an existing laboratory. you know, if they're doing really good job, they probably have opportunities of staying in the United States or whatever, Europe, or, so that they may not want to come back. Some will, though. They love the country that they grew up in, and of course it helped. They're not going to be too interested in coming back if they think the probability of them doing any more science is nil. So, you know, you have to somehow find the money to provide some research support.
Yes.
I'm not so much talking about supporting postdocs or things like that, but building up a laboratory, that's an expensive business.
For this special edition of Talk Vietnam, some of our audience members, who are students, sent us a few questions for you.
Oh my
Would you
God,
like to hear
okay.
them?
Okay, do I have to answer them? Okay, let's see.
So let's start with VNtienganh, 23 years old, from the Diplomatic Academy of Vietnam. He asked, is it difficult to study physics, and how did you approach your studies?
Okay, well, I just, you know, because of, I guess, all the stuff I did when I was very young, it was kind of quite natural for me to study physics. And of course, I was in a research lab that had, you know, 3 professors in it, so I always getting good advice. And there were, and I don't know, probably 8 or 10 graduate students, and so we, you know, learn from each other and stuff like that. So, you know, I think that's the best way for students to learn from each other more than from professors.
So his next question is, what is your next important project?
Oh God, I have no idea what my next important project. My research career is over now, and I unfortunately my lab is there and it still has lots of good equipment, but I don't have the time because of all the other things I do now to go in there and pretend like I'm a graduate student anymore.
So another audience member, Lê Phương Thảo, 21 years old, from Hanoi National University, asked, if you had to describe your discovery of the superfluidity of helium-3 in a way that even a primary student who has yet to learn physics at school could understand, what would you say?
I would say, I give up. No. I mean, it is. I think students have to understand something about the BCS theory. But basically, what happens is there are 2 kinds of particles in nature. Well, there's more than 2, but 2 varieties. There are particles with odd half-integral spin, like 1/2, 3/2. And there are those particles that have even spin, 0, 1 unit of angular momentum. And those particles behave very differently. The ones that have odd half-integral spin, 1/2, 3/2, those are, we call those Fermi particles, Fermi-Dirac particles. And they are antisocial, so they don't like each other. So you can't get 2 Fermi particles in the same quantum state. Whereas the other particles, I don't know, if this may be going beyond. I see
primary school.
So the other particles are Bose particles, which have an integral multiple of h bar angular momentum, and those particles are the ones that love each other. So helium-4 atoms, which have an integral spin, form a superfluid at a temperature of about 2.17 Kelvin. I'm not sure the number's exactly right, but around 2 Kelvin. Whereas helium-3 atoms, which are Fermi particles, they're the antisocial ones, don't form a superfluid until you get down to a temperature of order 1 to 2 thousandths of a degree. So it's a very complicated, very different sort of a process that leads to that kind of ordering. What was your question?
I don't think that would help our primary students.
Oh, no. Okay. Well.
But I'm sure all the physics students would understand.
Okay.
So in Vietnam, youngsters tend to choose jobs as their parents wish, with preference often given to business-related careers. They seem to not realize that science is also a good path with value. What do you think about the tendency for parents to encourage business? If you were asked to give Vietnamese parents some advice, what would it be?
I think that if you love your children, you should want them to have careers which are satisfying and rewarding. And if they're not interested in going into business, I think you shouldn't force them to do that. It's easy for me to say that.
You had great support from your parents.
I did.
Yeah. So, next question. Can you please give some advice to help Vietnamese children develop their scientific inclinations from a young age?
There's lots of books on physics theory, that's some starting at a very rather simple level. And so I think, you know, students that are willing to read, that's a first thing, okay, to provide them with books. And then I think, you know, if they have questions, it's important that there be someone there that can answer those questions, because they will have questions. But that's one side of it. But the other side is, if you want to go into experimental science, then you need a whole different set of skills. And I guess I started out, you know, when I was very young, you know, working with my hands and learning how to do things, and soldering irons and making transistor radios and all of that stuff. And even in the United States now, people won't do that anymore. So students don't actually learn those skills very, very quickly.
As a scientist, what principles guide you, and what or who inspires you most?
I don't know what you mean by what principles guide me. I try to be honest, okay? I work hard, but I don't work hard in order to work hard. I work hard because I'm fascinated with what I'm doing, and I'm interested in finding out what happens. So I do think that people that go into science can expect that they have to work hard, and they shouldn't look at that as a punishment or anything like that, but as an opportunity. I mean, there's nothing like discovering something at 2:30 in the morning.
So, what or who inspires you most?
I don't know if anyone inspires me anymore. I'm on the other side of that. I'm trying to inspire lots of young people. So I go around the country and around the world, you know, telling stories of discovery and you know, giving advice to students and things like that. And, the number that actually, you know, write back, dear Professor Osheroff, thank you for the advice you gave me. I've just discovered something. That doesn't happen very often, but I hope that I'm giving good advice, and that at some point someone will say thank you for what you did, but it hasn't happened so far.
So what role does your family play in your scientific success story?
Oh, well, first thing you have to understand is neither my wife, we don't have children. We never had children. I think we were both very passionate about our careers. She's a biochemist, and of course, I mean, I had just discovered superfluid helium-3, and so I think we have a very close marriage. We love each other, and I think we kind of make time to be together, but we never had children. And so when students ask me this question, I say, no, I think of you as my children, academic children. Yes, not,
So you're, as you said, intellectual offspring.
Yeah, exactly. Yeah.
Well, thank you so much, Professor Osheroff, for an absolutely inspiring conversation. We wish you all the best in your future endeavors, and hopefully see you soon in Vietnam again.
Okay, well, I look forward to coming back.
Thank you.
Thank you very much.
And that's all for a special edition of Talk Vietnam today with Professor Ashraf, the 1996 Nobel laureate in physics. I hope you have enjoyed the show as much as I did. I'm Ola Ding. Until next time, take care and goodbye for now.